Hi everyone and welcome. This is a technical session about continuous delivery techniques, and we're assuming you chose to come along because you're already doing CI or hopefully even CD. As you all know, continuous delivery helps teams become more agile, and even when done well can quicken the pace of innovation. Too often though, teams adopt continuous delivery without defining the right safety mechanisms to put in place. It's dangerous to leave out these mechanisms. After all, we don't want deployments setting things on fire. In this session, we'll show you some options to transform a typical software release process into one that will scale whilst making deployments safer. We're going to show you two demos, both detailing safety mechanisms for infrastructure and application deployments, like infrastructure pipelines, synthetic tests, Canary servers, and black days. Many elements of the code we use in our demos are already available in GitHub on the AWS Labs organization, so check it out. There's some great code in there that you can use as building blocks to integrate into your existing pipelines. In this session, we're going to use a bunch of services, and we can roughly group those into three different categories. Firstly, management services like CloudFormation that we'll use for defining the infrastructure as code, and CloudWatch for logging, alerting, and visualization. We're going to use some software deployment services to extend the functionality of our deployment pipelines, and the CodeStar services to orchestrate various aspects of the deployments. There are many other tools out there that do similar things, but today we use the AWS toolset as an example. Although most of you will know how to do CI/CD, there's still a little uncertainty about the definition of terms. So I just wanted to define these super quickly so that we're on the same page. Here at AWS, we define continuous integration as building and testing automatically on check-in. Continuous delivery is when you have your whole pipeline automated, but with a manual approval process to serve as a gate, so people can sanity check releases before they go out to production. Continuous deployment is when you're able to check in code and have it released to prod with no manual intervention whatsoever. Now that's super powerful, but you need to have a very mature deployment pipeline to pull that off. Now that maturity isn't just technical. Sure, you need to make sure you're automating and testing all the things, but you also have to ensure your business processes are well defined and your business's risk profile is being taken into account. For example, your business may not want you to make changes on certain days of the year when it's super busy. Or perhaps when you do make a change, your company may want to validate it on a small subset of your production environment before you roll it out everywhere. Maybe your business wants to push synthetic traffic through to test that your changes don't lead to functional regression issues. Anyway, this is the problem we're going to explore in our demos, how you can enhance your pipeline to model the more challenging needs of your business and to reduce risk around your deployments. I just want to highlight a few of the key characteristics of a good pipeline that we'll be focusing on in this session. You want to define your pipeline with code so that you can check it into your version control system. Now, this is increasingly important as your pipeline matures, as it will become more complex despite your best efforts at retaining simplicity. And when things get complex, you need to be able to drill down on how they will change over time. You can't just click around in the GUI. A good pipeline tool should be extensible. A demo will explore how extensibility is important for enhancing pipeline functionality. A pipeline has to be able to give fast feedback on whatever it's doing. If a developer has to check in code and then wait half an hour for it to build, deploy, and then run security tests or generate an AMI before they get feedback on what's happening, they're just not going to use it. Get the most obvious things out of the way and then get feedback. Do your security testing and such at a later stage. So I just want to touch on immutable and immutable infrastructure. With both mutable and immutable servers, you'll start out by deploying version 1 of your brand new app onto both servers and bringing them online. You'll then bring those servers into service. The difference comes into play when you start changing things. With mutable servers, you'll often need to bring down your server, even briefly, to update your application. Now with immutable servers, you can just leave it running, bring a new server up with the new version of your app on it, and then just redirect the user traffic to that new instance. So there's way less downtime in your immutable deployments. Updating your OS will likely result in a longer outage, and this can be avoided on immutable servers. There are additional advantages to using immutable servers beyond just reducing downtime. When we're looking at mutable infrastructure, we're doing an in-place deployment. So if there's a failure during the deployment process, in order to roll back, we need to do another deployment, which can take considerable time depending on how you did it in the first place. Now, when we're looking at immutable servers, we still have the previous infrastructure running, so you can quickly roll back if there's some sort of issue during deployment. Another thing to consider with mutable servers is that they're usually long-lived servers, where we're constantly doing in-place updates. So over time, we can get configuration drift. So in order to baseline the configuration and bring it back to a new state, we need to run some configuration management tools, and that adds additional complexity and overhead to the process. If we contrast that to immutable servers, we can always go back to a known state, either an Amazon machine image or a container image, and we're doing that on every deployment. The AWS services you see at the bottom there can all be used to do deployments. Beanstalk is an awesome tool that you can help orchestrate your infrastructure with. ECS provides powerful container management functionality, but CodeDeploy is the only service that's completely dedicated to deployments, and as such, it's very powerful for that purpose. The key takeaway here is that all three services can do both mutable and immutable deployments. One of the best things about infrastructure as code is that it allows us to use deployment pipelines for your infrastructure. The lifecycle can be managed in a similar way to your application, passing through similar stages. A DevOps engineer can check in infrastructure code, then lint or validate the template. They can then run unit tests using CloudFormation change sets or something similar. They might want to generate AMIs and store them in an artifact repo, and then deploy the change to an environment by having the pipeline push the template to CloudFormation, which will run a stack update. The important thing to notice is that we're doing this so that we have a repeatable pattern for our infrastructure changes that's similar to the standard application delivery lifecycle we've all been doing for a very long time. This helps us speed up our deployment whilst reducing the risk of infrastructure deployments going bad. I won't walk through the application lifecycle, as you're all aware of how that usually works. My point here is that there are similarities between the two that you can leverage to improve your deployment safety. So in our demo, we've got one repo with 2 CloudFormation templates and 2 code pipelines in it. The first pipeline is what we just looked at, an infrastructure pipeline. So that's the one we use to pass an infrastructure template to that defines our infrastructure, and it'll run through that pipeline. When someone wants to change the auto-scaling group parameters or redefine the deployment groups in CodeDeploy, they'll check in their code change, and this is the pipeline that will kick off. Now, with a little bit of that inception, as part of that, it will build out the application pipeline, which is what our code for the application will pass through to build. Now, this application pipeline is what we'll explore in our second demo later on. It includes the various application deployment techniques we'll explore. Now, to run this through in a little bit more detail, let's say our demo company has a microservices architecture and wants to provide developers some infrastructure and application scaffolding to use when they want to build a new service. This stencil will give developers a consistent pattern for building their microservices, making everyone's lives easier. They have a Tomcat stencil repo that can be used for this exact purpose. A developer building a new app will clone the stencil repo into their own new repo. Now, this repo contains 3 elements: a Bootstrap CloudFormation template, an infrastructure CloudFormation template, and the stencil app code, which you might choose to update at this point in time with the first version of your app. The next step is to execute the Bootstrap CloudFormation template. Now, this template has one purpose, and that's to build the infrastructure pipeline. Now, this infrastructure pipeline is the engine that creates and changes all the infrastructure that the application runs on, based on the infrastructure CloudFormation template, including our application pipeline. Executing the infrastructure pipeline will invoke that template and execute it. That will create the stack. So that stack in our case is an EC2 instance in an auto-scaling group. It's an ELB, an application pipeline, CodeBuild, and CodeDeploy. That application pipeline for our demo has a whole bunch of other services behind it though, including Lambda, DynamoDB, SNS, and they're all orchestrating various elements of the testing infrastructure for our application, but we'll focus more on that later. So let's say a DevOps engineer wants to change the infrastructure by adding an EC2 instance to the auto-scaling group. They'll make a change to the infrastructure template and check it into the code commit repo. This will trigger the infrastructure pipeline, and the pipeline will then issue the stack update, executing our infrastructure changes. In our case, we're going to be incrementing the target number of servers in our auto-scaling group from 1 to 2. So this is where the inception takes place. We're using the infrastructure pipeline to build out the application pipeline and all of the logic for testing functionality baked into that. Let's see a demo of how this works practically. Here we have the infrastructure continuous deployment pipeline that's been bootstrapped. So we have the source stage and then the deployment stage. In the source stage, that's code commit, we have a validation stage, which is validating the CloudFormation, and then we either create or update the existing CloudFormation stack. So what we're going to do here is increment the desired capacity in our production auto-scaling group from 1 to 2. Now on the validation step there, I could use a DSL and generate the template from CFN DSL, for example. Now here we can see the auto-scaling group with the current desired capacity of 1. Now in the terminal here, I'm going to edit the CloudFormation template and search for the production auto-scaling group resource and just increment that desired capacity from 1 to 2. There we go. Then I'm going to commit that change into the code commit repository. And then that's going to kick off the code pipeline. So just refreshing, you can see it passing through code commit, then being picked up in the validation. So that template's been validated and then the infrastructure update's been applied. So just refreshing the console, you can see the desired capacity is being incremented from 1 to 2. So you can see CloudFormation is a really powerful way to track changes in our infrastructure because we can put it into a repository and then when the changes were made, we can see who made them and also how the things diff over time. So we can see how the infrastructure evolves. Okay, so let's look at the application tier now. App code is more complex than infra code. At AWS, for example, we have around 90 services, only a small portion of which are counted as infrastructure. If you multiply all of those services by all of the different APIs, you still have an upper bound to the total number of permutations in your infra code. Application code doesn't have this limit, and we use the app code to model our business processes, of which there are innumerable possibilities. So this means that our application pipelines will model how we make changes within this complexity. Let's walk through some more advanced application deployment patterns that can help us reduce the risk of changing things in our applications. Firstly, we're going to look at continuous production testing and synthetic tests, where they're going to look at how to segment the production environment and use Canary deployments. And then we're going to show you how to halt promotions with gates like time-bound deployment windows. Let's start by looking at how user traffic works with our servers and how synthetic traffic works. When a user requests content from our server, it'll respond to them and it'll also propagate a message out to our monitoring server to let them know if the request was responded to properly or not. Now, this will go into our production metrics stream. A synthetic test will work exactly the same way. It'll send a request to our service, a response will come back, and the server will push some data to our monitoring system. In addition though, the synthetic test will push data about whether the test passed or failed based on the response it receives back to the CloudWatch metrics stream. We can invoke these tests every minute, and we'll be doing that with CloudWatch events. And if we have a problem and we have a regression in our business critical functionality, then we can send that message back to CloudWatch and our alarms will fire. So why are there two metric streams? The first metric is just used to validate requests and responses are flowing. That's all. Just that there's no 500 HTTP errors or anything like that happening. The second metric is to validate whether a functional element of the app stops working. For example, the buy button disappears or login prompt stops working. The synthetic test will confirm this functionality on this metric stream. For our demo, we built a single-page application that displays a picture of a horse. Pretty straightforward. So how do you functionally test that though? Well, I thought, we want to check that it shows a picture of a horse. So let's use recognition. Amazon Recognition is a new service that performs image analysis and provides semantic tags for those images. We wanted to keep it super simple and single purpose. Our synthetic test just tests for one thing, and that's whether the image is horsey. We call recognition using Lambda to check that it is correctly tagging horse, and if it has a different picture, it'll fail. We schedule CloudWatch events to run that test periodically to trigger the test. We then capture that within CloudWatch metrics so we can manage and visualize it. Synthetic tests are usually done using New Relic or App Dynamics in a scheduled fashion, We want to incorporate it into our pipelines though, so it runs every time something changes. Another safety pattern for deployments is segmenting your production environment. This is a way to break up your deployment so you can get more information about a deployment for a segment as it's rolling out. You can think of it as a segment as a blast radius. So if something goes bad, it defines the full scope of that issue. You can contain it in that sense. Some common segment types are region, which can then be further broken down into availability zones, intra-AZ groupings based on some criteria you define, and canaries. So all a canary host is just a single host that you deploy to within your production environment. And we're going to show you how to do that really easily with CodeDeploy. So how does that work? Well, you might divide your environment up, usually by AZs, and you start by issuing your deployment just to the Canary instance. Now that instance will get its version incremented, you run a post-deployment test, and if that passes, roll it out to the first AZ. Run a post-deployment test, and if that passes, roll it out to the rest of your availability zones. As a side note, this applies with both mutable and immutable deployments. To set this up, the first step is to configure your deployment groups. As I mentioned earlier, there are other tools available, but for our demo, we're using CodeDeploy to model our segments, as it makes it really easy. It allows you to use tags or auto-scaling groups to carve up the deployment segments. You see here a screenshot of the part of the console where you define these. So when you're deploying to your segments, it follows a pretty simple pattern like we just described. Deploy to the smallest segment with the smallest blast radius. And for us, that's the Canary host. Run a test against it, validate that it worked, then issue the deployment to the first AZ, run a post-deployment test. If that passes, issue it to the other availability zones. So you're increasing the scope of your deployment as you gain confidence about the way that it's being issued out and whether it's being successful or not. Note that we don't run post-deployment tests here, and that's because we're already running our synthetic test to capture anything wrong within the deployment. So how do you gain that confidence? Well, you want to get data. CloudWatch metrics is a good place to aggregate and view data about what's going on. You want to make sure no service alarms are fired, and we're using CloudWatch alarms for that. You want to make sure that the test hasn't timed out due to some strange code glitch. So with those Canary servers, you might want to configure them to serve up production traffic and make sure they participate in the production metric stream. You want to treat them just like every other server. There's nothing special about them. The only thing that's different about a Canary host is that it has its own metric stream, and you use that validations from that metric stream. You don't want to be passing the Canary metric into the production stream, as you'll get lost in all that data. Finally, it's important to handle changes during sensitive times carefully. Many of you, like myself, will have been in one of those situations where you're trying to rush out a performance improvement before a really busy period and things have gone bad. Now, one of the problems is that we usually handle this by telling people, please don't deploy today. Now, I personally have been in those situations where someone comes in late to the office and makes a change because they didn't know otherwise. Here we think that it's really important. So instead of relying on word of mouth or manual processes, why not convert this into a business process in code? We want to let our developers make changes any time they want without worrying about it. So we built a mechanism that halts deployments during sensitive time windows. At Amazon, we call those periods black days. And for our demo, we've built a black day calendar with CodePipeline, which is orchestrated using DynamoDB. Now we use the approvals to pause the deployments, and Lambda functions will automatically approve when we're clear of the black day window. So for our demo, we'll do a code update into the application code commit repo. That'll get picked up by CodePipeline. It'll then do the build, run the time window approval, which is a black day validation check. Then it will do the deployment to the one little segment, the Canary deploy. And then it'll run our synthetic tests, our post-deployment tests. You can see on the right there, the Canary recognition test. Now that's the one that's checking for the horsiness of the images that we're displaying in our app. You'll have an approval step just to validate that those two tests have passed successfully, and then a production deployment. Let's run through a demo of how that works. Here I have the Summit app pipeline. So I have the source stage, the build stage, and then some segmentation using a Canary deployment and time window approval. So here's the application. I'm hitting the Canary environment directly through the Canary endpoint and the production environment where the Canary is also serving traffic, so we can see that they're the same. It's essential for our demo organization that we're showing a horse here. If there's no horse, something's gone terribly wrong. So what I'm going to do here is edit the home page. We're going to go in and change the color of the background for the application. Then we're going to go and change the image that's being shown as well. Going to check that back in to source control into code commit. And push that up. Okay, so that's being pushed, that's working successfully. And you can see that we've got an endpoint for where that's being pushed to. So here we're refreshing the pipeline and it's been picked up already. It's passing through code commit, passing through the build stage and the Tomcat app's being built. And then in the time window approval, you can see that this is where we've got a black day calendar. So you can see that today is a black day, so we have it flagged so that this will not progress beyond this point. So you can see that it's waiting for approval right now. So we need to manually approve that to progress it. So the demo must go on. Okay, and so that's now being pushed through and being deployed onto the Canary host. So we're now running the post-deployment test, and you can see the Canary recognition test has failed there. And that's because it's detected that there's an issue with the image. So you can click on the button and progress through. So looking at CloudWatch dashboard, you can see that the production tests are looking good. They're okay. But in the alarm state, it's a bit different. So you can see here that the recognition synthetic test has failed. So looking at that on a minute-by-minute interval, you can see that there's been a couple of failures there. So that's where our problem's coming from. Now, if we go back to the console, you can see that we're stuck at that stage. And if we look at the production environment, it's showing a horse just fine. But if we look at the Canary, there's the problem. We've got a donkey. Now, donkey clearly is not a horse, and that is a big problem for our demo organization. So what are we going to do? Let's fix it. It's a little hot fix being issued, and we're going to change back to make sure that we're pushing the right image into the application. And then we commit that to code commit, push it up. That'll get picked up by the pipeline. It'll pass through that source stage and then get built. The Tomcat application is going to get built successfully. And now we're at that time window approval. Now that passed automatically because we've reconfigured that so that today is no longer a black day. So that automatically got propagated through onto the Canary. And you can see that that's been reflected on the Canary host happily. So that's great news. Now let's refresh production. Sure enough, we're showing the Canary host and production both good. So those tests will pass at this stage, we're expecting. Happy days. Okay, and so we've got a Canary approval. Now that requires 5 successful metrics within a 20-minute time frame for that to progress through. So this is another gate that we've set up. So we just refresh that 5 times to propagate those metrics through, simulate a bit of traffic flowing. You can see here we've got this transition halted. Now the reason for that is because synthetic tests were failing before. So we want to have a manual approval stage to say that somebody has intervened and validated that those tests have passed. So you can see that's been rolled out to production now. And sure enough, the Canary host is looking good. The production environment's good. Give it a refresh, and it's now showing the Canary because the Canary is one of our 2 production servers. So if we refresh the metrics, you can see there's no longer any in the alarm state. We'll refresh that dashboard, and the synthetic tests alarm has gone. and now you can see that we're good. So the production deployment was successful and we've passed through all of the tests that we needed to pass. So there's an example of how you can use recognition, and we can pass through a number of gates, which are security mechanisms to make sure that we don't fail anything in production. In this session, we've explored how you can improve the safety of your deployment pipelines and how you can nest an application pipeline within an infrastructure pipeline. We also looked at how you can improve the safety of your application deployments using deployment-attached synthetic tests, segmenting production using Canary deployments, and halting promotions with Black Day gates. So, as I said at the start, check out the AWS Labs organization in GitHub. You can go there and check for CodePipeline and find all the different building blocks that we use to create this demo right there. So there's lots of other stuff in there as well, and we highly recommend you have a look through there. Now, I encourage you to think big about what your organization's currently doing manually, what sort of business processes there are, and what you can automate to improve the state of things. Code's available on GitHub, so you can go and pick that up and run with it to build something small as a proof of concept right now. Thank you for your time. Please complete the survey to let us know what you thought, and don't forget to engage with us on social media to stay up to date.